Okay, Unit 8, Target 3 is about identifying altitudes in a triangle. An altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or to the line that contains the opposite side. So key parts there are it's from a vertex, and it's a perpendicular segment to the opposite side. I put an H on my diagrams because a lot of times the altitude is referred to as the height of the triangle. If you're finding the area of the triangle and you need to do 1/2 base times height, which is the area formula, the height of the triangle is sometimes inside the triangle. It also can be drawn outside the triangle. And so here's just a couple examples of altitudes that are drawn in or out of the triangle, and then even an altitude that can be on the side of a triangle. If it's a right triangle, then one of the legs of the triangle is actually the altitude. So an altitude is drawn from a vertex perpendicular to the opposite side, or the line containing the opposite side. Here are some altitudes drawn for you from the vertex that's been starred. So you can see that each one of those goes from a vertex and then is perpendicular to the opposite side. A couple of those are inside the triangle, a couple are outside the triangle. Like this bottom one on the right, you can extend the side length to see where that altitude is. You can draw multiple altitudes for the same triangle. So there's one already there in blue, and here's another one in red. Altitudes always intersect at a right angle, which means they're equal to 90 degrees. So in this problem, they said angle DBC, which is pointed to with the arrow, is equal to x squared plus 26. And so x squared plus 26 equals 90. Subtracting 26 on both sides gives you x squared equals 64. We take the square root of that. And so x is equal to 8 and -8. Because if you do -8 squared plus 26, you still get 90 degrees. And if you do +8 squared plus 26, you get 90 degrees. When you take a square root, we should do a positive and negative, but in geometry, you just need to check that the negative makes sense in the problem. An example of one that doesn't make sense is if I had a x, 4, 5 right triangle. Then when I set this up with the Pythagorean theorem, x squared plus 4 squared equals 5 squared. That leads to a solution of x squared equals 9 and x equals +3 and -3. The -3 doesn't make sense as a side of a triangle, so we ignore it and just pay attention to the positive. That's what's happened so far in problems, and we need to make sure that we do the positive and the negative for problems like this because it works. Also want to point out that when you draw the 3 altitudes inside a triangle, or outside, you draw the 3 altitudes, they will intersect sometimes inside the triangle, they will intersect sometimes outside the triangle, and they will intersect sometimes on the edge of the triangle at the right angle. The point of concurrency, their point of intersection, is called the orthocenter. Ortho is from the word orthogonal, which means having to do with right angles. So a little reminder there. And then there is no special properties that we need to know about the orthocenter like we had for the circumcenter and the incenter. So that is target 3.